I am a morphologist, but my group of study is reptiles, more specifically squamates that are lizards and snakes. This is my group of study. But now particularly I'm interested in the miniaturization in this group. Then, yeah, I'm studying how the morphology change when the species become smaller. Traditionally, people use the descriptions, right? We use words to describe the shape, the general morphology. But recently, a lot of people is using more geometric morphometrics. That maybe I think the traditional description with words is still valuable, but the new methods that we are using now that are basically numerical, it allows us to compare things in a more controlled way. Yeah, we can compare things in a mathematical way. Then it's different. Both approaches are valuable, but you can get different things from each one. For example, my project now is about the evolution of the inner ear of a group of lizards from South America, mainly. And at the beginning, it was very hard to define the landmarks, the places where you put the points. Because the inner ear is an empty space, it's a cavity inside the skull. Then you have to create a model of that empty space. But when you do that, it is very hard to figure out the homologous landmark. It's very different as, for example, if you are using skulls, because in a skull you can just use the sutures between bones. But here is just a 3D thing without clear landmarks. Yeah, then you have to be very careful to understand the morphology very clearly to set some homologous landmarks. Checkpoint is the landmarking software that I'm using now, and I think it is very easy to use. You don't have to worry a lot because it is very intuitive. Also, one important thing is that it's very stable. So I have used other softwares that sometimes you are placing your landmarks and in a point your software crash and you waste all your work. But Checkpoint is, at least with the data sets I'm using, it is very stable. I have never had those problems. Then it makes your work faster because you don't have to do again things. And also, I think the visualization is very clear, and the way that you can rotate the specimens to find the hard places is really good. I think the most important thing for me is the stability, yeah, because sometimes in some specimens you are placing hundreds of landmarks, and if something happen and the program crash, you waste a lot of time. But with this Checkpoint, the thing is very, very stable. Also, when you are using Corpse, other software, you have a limit of points that you can use, but in Checkpoint, it is unlimited. Then you can do long Corpse. First thing, you have to understand the morphology of the thing that you are studying, right? You have to define different structures, and with the landmarks, basically what I'm trying to do is delimit the connection between those different structures that compose the whole thing that you are studying. But as I told you, in the case of my current project, it is hard because you don't have like the clear distinctions between structures. And basically, what you have to do is look for a position that indicates a change in the structure, but you are not totally sure.
Mm-hmm.
What I'm doing is that I'm the only one that I'm placing the landmarks because to maintain the same perception of the morphology. Yes. Then what I have done is just I look for places that can be considered homologous or at least that are comparable between specimens.
Mm-hmm.
For example, this is a good example of a good place because here we have three structures that meet together. Then it is easy to find this specific place here that you have the anterior ampulla here, the lateral ampulla, and this other ventral structure here that meet together in this point. Then in this case, it is easy to find an homologous place. But for example, here, where we have the lateral ampulla here and the lateral canal, you can see that maybe it depends on the perception of the person that is placing the landmarks, because you really don't have a clear distinction between where this structure ends and where this starts. Then basically you have to try to do the same way for all the specimens, but really we don't have like something like a suture or something that indicates a clear distinction between the structures. So once I define the landmarks, I for example, what I'm trying to do here is create patches that covers the whole structure. For example, here, this structure here is the lateral canal. Then what I try to do is connect all the landmarks that I'm using to describe the shape of the lateral canal and connect them with these curves. In that way, I can have like a representation of the outline of this structure. And basically, I have tried to do it with all the different parts of the inner ear. So we have the canals here, the vestibule, the ampullas. So I have different set of patches to catch the shape.
Can I see them?
What did you see? What did you say?
Can I see the patches?
Yeah, when I'm talking to patches is, for example, here in the vestibule, we have this landmark, then we have this one here, and this is the last one, and all of them are connected by curves. Then this space that is in between the curves is what I call a patch.
Okay, I see.
So yeah, this is my approach for this particular project. I have different specimens that you can see. For example, this have the canals are higher. And for example, this other, you can see that the canals are closer to the vestibule. Then those are the things that I'm trying to catch with the landmarking.
Super cool.
To describe the variation between the species, among the species. Example here, this is if you click here, this arrow with the big yellow ball is the single points that we usually use for the true landmarks, that are the landmarks that represent an homologous place. Then for example, one of the points that I'm using is this one, that is the connection between this canal here and this ventral part of the inner ear. So I place the landmark here. And for example, my next one is here. That is the tip of this process here. Another one I use here. So after that, I connect those points using curves.
Uh-huh. Super cool.
And here, for example, this curve is 10 semi-landmarks, like this. And here now I have a set of landmarks that describe the shape of this ventral part of the inner ear. Yeah. With other softwares, it is very common that the program crash. And you just have to start again. So that's what I mean when I am talking of stability, right? That really this software have never crashed to me. There is a hypothesis that suggests that the inner ear is related to the shape of the inner ear is related to ecological traits that the species have. Then this hypothesis suggests that, for example, there is like a kind of inner ear that match the species that are, for example, arboreal or semi-aquatic or fossorial.
Mm-hmm.
Then this is a hypothesis, but people haven't really test that hypothesis in a mathematical way, right? Usually people just study the shape, do a description, and find some things that indicates this relation between the ecology and the inner ear morphology. But with the geometric morphometrics, we can compare the different kinds of inner ears in a more controlled way. So this is important because it can be it looks like that this hypothesis is not totally correct. It looks like that not always the shape of the inner ear is related to ecology, but in some cases it is more related with some constraints like the size of the skull, or, for example, species that are fossorial, they have a particular morphology similar to snakes, for example. Mm-hmm. And those species share like a similar morphology. Then probably it is not because the ecology, but for other causes like the shape or phylogenetic constraints.